Hi there, Jim here. So in an earlier video, we looked at this ATORCH DL24, and we looked at sort of what I call the basic operation used to test the capacity of, uh, of a battery, so capacity tester. This video, what I'm going to be doing is I'm going to be looking at the configuration screen, and so I'm going to be zoomed in pretty tightly. Here we are zoomed in on the display and the control buttons, and you can see that there are 4 control buttons here. There's a button labeled setup, a button here which has a little minus underneath it. This button has a little plus underneath it, and this one is called start. And so it's a little bit confusing because the setup button is used to set up the items that are shown here, and I showed how these items can be configured in an earlier video. But if we want to enter the configuration menu, where we enter a lot of the sort of foundational settings, we have to use the start button. And so a long press on the start button takes us into the menu, what it calls the menu. And then from here, we can move through. You can see there are 13 different lines here. And we'll go through all of these. And the setup button is what's used to move to the next line. So every time we press the setup button, it goes over to the next line. Okay. Now, the setup button is used to go to the next line. The start button is often used to invoke a setting or to trigger a setting. Okay, so if we go here and we want to, for example, clear the data, we'll press the start button, and you can see it flashes an OK to say that it's done that. So that's fairly typical, where the setup is used to select a row and the start button is used to invoke it. Now, this one is for the language. You can see right now English is selected. We can use the plus and minus keys to change it. So now that's changed it to Chinese. Press again, change it back. So there are only 2 languages stored here, and so if you ever mess up and get it into Chinese, it's quite easy to get it back to English, right? Because you can see right away. So we've talked about the first 2. Then the third item is a calibration type of setting, and it's current and voltage clear to 0. So we basically, in this, this is used to set the 0 points or the zero calibration for the unit. So we go here, and you have to make sure that there's nothing connected, no voltage, no current, and then press the start button and OK. So now at this point, everything has been zeroed. And so if we go, if we exit here to the display, you can see everything is zeroed. It kind of picks up every once in a while a twitch on the voltage line. It's very sensitive. Okay, but there is no voltage connected here at this point. So that was the 0 function. Now, a little trickier is the 30 volt reference voltage and then the 3 amp reference current. So I'm going to come back to those because in order to do these, you've got to have a defined controlled input source for these. And so it's a little bit tricky and time consuming, and I'll show how we do that. Okay, so, but for the 30 volt reference source, we have to have, for the 30 volt reference, we have to have a reference source that we can then trigger on. Okay, so we'll skip those for a second. Display brightness, this is currently set at 9, and we can use the plus and minus keys to adjust the brightness levels. So usually display brightness is the brightness that it operates at while it's functioning. And then we have a standby brightness. So after a certain standby time, and that's shown here below, after a certain standby time, it'll dim the display and it keeps operating. Now, when we're on this particular row, it does show us, even though we're pressing the buttons, it shows us what that looks like. And so I think the default brightness for standby is something like 6 or 5. Okay, so that's what standby brightness is. And there's no, you don't have to do anything to trigger these. They're, or to set them. They're set once you change them. So when I go to the next line, okay, you can see now it's in the active display brightness. The setting of 5 is there. So there's no need to kind of say, okay, this is the brightness I want to use. Then there's standby time. So standby time is just the amount of time before the display goes from its sort of full brightness setting, or the 6th setting, to the standby brightness. And we can adjust that once again with the plus and minus keys. Okay, and this is controlled in seconds. And believe it or not, there is not a permanent stay on all the time. If you hold the button down, it starts going faster. The maximum time here is 99 seconds. So the maximum standby time is 99 seconds. And then you can go all the way down to the bottom. And the minimum time before it enters standby is 1 second. Okay, so it'll go to standby fairly quickly. So the default that this comes with is 60. I'm just going to set it back to 60. It would be nice if there was an always on kind of setting, but I guess you could always do that by making the standby brightness full brightness. So that's just how they set that up. And then we have 2 lines here. There's a line to do the temperature correction, and that's the temperature on the input sensor. And then there's the temperature correction, the input sensor that's internal to the unit. And then you can also do temperature correction on the external sensor, which I don't have hooked up. But they're both done the same way. And so there isn't really a facility here to feed in a reference temperature. So you kind of have to just know what the current temperature is. And when you press the plus and minus buttons, so which I'm going to start doing in a second, it adjusts what the current temperature is. Okay, so that takes it down by ½ degree centigrade. So it's 20.7. The room I'm in, the temperature here is below 20. And so if I press minus again, it says it's 20.1, 20.2. Because the temperature varies a little bit, it's a little tricky to tell, but it is always changing the value by ½ degree centigrade. So if I press minus again, we'll go from 20.2 or 20.1 to 19.7 or 19.6. There we go, see? And so we can kind of, and so that's how the temperature correction is done, just plus and minus, because this isn't really precise. You just want to kind of get into the ballpark so that when it's sensing the temperature, you have a good sense of how hot the sensor is getting, or how hot the load device, the SCR, I think, or the transistor in there is getting. And do that once more, so about 19. So that's about the temperature in the room here. And so this temperature, that mode of temperature correction is the same whether it's the internal sensor that's located somewhere inside here underneath the heatsink or the external sensor. Okay, now the next one, there's overpower. And so this unit, technically, this is spec'd to 150 watts based on the data from ATORCH, but they by default ship it with an overpower where it'll basically stop operation at 185 watts. And we can adjust that in 1 watt increments if we want to have it cut off or alarm us if the power level goes beyond this threshold. And so really the idea here, and I'm just going to set it down to 150 watts. The idea here is if we're going to destroy the unit, we don't want to do that. So we want to get a warning when the power draw of the unit exceeds this level. So that's what that is. And then the next one here is default settings. Now, one of the things that is a little bit interesting here is that I've been a little challenged to get default settings to reset everything, because you'll notice that we made some adjustments here. And if I do the OK, the trigger here, it says OK, but nothing's changed. Well, the temperature correction changed here, but the overpower didn't change. And so that's a little bit curious for me, because it really means that the only there's really only one default setting here of any meaning, which is the temperature correction, and I'm not sure why that's so important. It would be handy if it reset all of the settings to the default, but the only thing that it changes is the temperature correction. And then, of course, the last thing being exit, and when we trigger on that, it goes back to the main display. Okay, so the last two things that I'm going to show are the settings for the 30 volt reference voltage and 3 amp reference current. And so the idea here is that we go through and we calibrate the 0 point. And one of the things is because the test leads are not connected to anything, there's a little bit of ghosting there. So I'm just going to connect the leads. So I have a bench supply, and I'm going to connect the leads to the bench supply for a couple of purposes. First off, to 0, because if we're connected here, it's not on right now, and so it'll allow us to 0 quite easily. Okay, so the leads are connected now, and so that'll prevent the ghosting that we were seeing here. So now I'm going to go here, and I'm going to say set up. Okay, so now that's zeroed. Okay, now we want to get the other part of the range here, and so we want to feed in a 30 volt reference voltage. And so what I'm going to do is I'm going to set up that voltage. I'm going to set up 30 volts on my bench supply. And so if you have you need to have a controlled power source to do this. You can't just do it with anything, because you're trying to calibrate it, so it needs to be fairly accurate. Okay, and so I've now set it to 30 volts. Turn it on, and we can see that the readout here, 2991, 93, 94. So that's close, but not quite. The bench supply is oscillating between 30 volts dead on. So that's 30 volts dead on right now, and 29.999. So there's sort of a 1 millivolt oscillation, if you will. But at this point, the bench supply is giving me exactly 30 volts. And so what I'm going to do when I'm on that row, even though is showing what it thinks is 29.997. As soon as I press the start button, okay, that says that's exactly 30 volts. And so now we can see it's showing 30 volts. And of course it does drift a little bit, but the bench supply is giving me exactly 30 volts. This is a shot of the bench supply showing the 30 amps, sorry, the 30 volts that it's producing. And you can see it's not really jittering much. It's pretty much dead on at 30 volts. And of course, at this point, there's not a load triggered. It's just feeding out 30 volts. And that's the voltage that was used to calibrate the load. And so that's how we calibrate the voltage. Now, the next thing is the current. Now, to calibrate the current, we are going to need to put a load onto the unit. And that's the tricky part here. How do we put a load onto this system, and how do we make sure that the load is 3 amps? Because that's the calibration load that it's looking for. And so I'm just going to zoom out a little bit, and we'll have a look at what's involved in doing that. In order to calibrate the current, we have to be able to provide a current load, and we have to be able to do that in a kind of a steady fashion while things are operating. And so to do that, I've got another unit here. This is also from ATORCH. It's a different style of load and capacity meter. The key thing about this other unit is that the load is set up using these two knobs here. One is for coarse adjustment and one is for fine adjustment. And the idea here is this is a very sort of sensitive way of controlling the current, because I want to get the current as dead on to 3 amps as I possibly can. Okay, and so what I've got is the ATORCH is currently hooked up to my bench supply. The bench supply is currently set to output about 12 volts, and it's I've got the current limit set to 4 amps. Now, it's not on right now, but the trick here is to hook up this, your load, into this port on the side here. So this is a location where another load can go through, okay? But with that other load going through, there'll be some current sensing. Now, the leads here have just popped off. Okay, and so I'm going to zoom in on the load while we're doing this so you can see exactly what's happening. Hopefully the contacts don't pop off here while I'm doing that. So I just want to move these lines out of the way. Make sure nothing touches. There's going to be a fair amount of power flowing through. And so there we are. Now let's zoom in here. All right, so I've zoomed in on the display of the load. Now I haven't turned on the voltage supply, so right now there's nothing coming into the system. So I'm going to turn on the voltage supply. The voltage is set to output 12 volts and a current limit of 4 amps. Okay, so I turn that on, and I'm seeing now, based on the sensitivity of this, is showing 11.9 or 12 volts. The bench supply is steady at 12 volts, but I'm not drawing any current. And so now what I'm going to do is I'm going to start tweaking this. Now the current from the bench supply is flowing into the other unit, and it's bridged across from the load output. And so as I start to turn this up, and the coarse adjustment is fairly sensitive here. Okay, you can see there. So now got that. Okay, 303. I need to turn it a little low. And so I'm showing 2.81. Now I'm going to use the fine adjustment knob. Oops, a little too much. Okay, so now I'm drawing exactly 3 amps, and that's causing a little bit of a voltage drop. So the total power output in the system here is about 36 watts, and so that's why the fans are running. And so at this point, I've got a 3 amp load. Okay, the voltage is not so critical because we're not calibrating voltage at this stage, we're calibrating current. So now you can see I've got a stable 3 amp load that's running here that this device is generating. Now let's switch back and take a look at what's going on the main unit that we're calibrating. Okay, now here we are back at the DL24 display, and we can see that it's reading a certain load here that's sort of jumping around. And so what we want to do is we want to, now that we have a 3 amp load that's coming in, and that's a stable 3 amp load, that's why we are using that other device to generate a load that's not sort of jumping all around all over the map. We're going to hit the start button. Okay, and that has basically said that's 3 amps. Now the load varies a little bit as time goes on, and the metering varies a little bit. I can do that one more time. Okay, so that basically set what the 3 amp load is. So that's the 3 amp load calibration. I've gone through all the configuration settings on the DL24 menu page, and more importantly, I've shown how to calibrate the DL24 using a voltage reference and a current reference. If you found this video useful, please give it a thumbs up, and please subscribe to my channel. Thanks for watching.